everyone. I'm Michaela Parker, founder and executive director for the Alliance for Data Science and AI, or ADSA, and I'm here to welcome you to our new webinar series, Building the Future of Data Science and AI in Higher Ed, Lessons from Academic Leadership at the Front Lines. In this series, we're calling on our colleagues in the ADSA community to share their experiences building academic initiatives and programs in data science and AI. The idea here is they will tell you what worked, maybe a little of what didn't work, and hopefully sharing their stories will help you on your own builder journey. Before we begin, for those of you unfamiliar with ADSA, we are a community of data science and AI leaders, practitioners, and educators who believe in a just, equitable future where data science and AI are thoughtfully applied in all domains for the benefit of all. You can learn more about our events and activities on our website. The URL is on this slide. And just a quick reminder that this event, like all ADSA events, is governed by the ADSA Code of Conduct, which you can find linked at this QR code or in the footer of our website. Today's Builder lessons are about curriculum development. I'm joined by my colleagues Sarah Supp from Denison University and Linda Clark from Brown University, who will talk about their experiences building curricula for data science and AI courses and programs, what successes they've seen, and considerations for others who are doing the same. But first, they're going to begin by giving us a quick overview of their data science and AI programs. Then I'll turn the Q&A over to our moderator for today, Program Manager Steve Van Tile. So Linda, I believe you are first up. Why don't you jump on in?
Thank you so much for the introduction, and thank you everyone for attending today. I'm really excited to be here, and hopefully some of my mishaps will be beneficial for everybody here. I'm a faculty member in the Brown University Data Science Institute. We are an institute. We are not housed in another academic unit. We do report directly to the provost. We have a very strong interdisciplinary and socio-technical focus in our center, or in our institute. We have two centers in our institute. We have a Center for Computational Molecular Biology, and we have a Center for Responsibility, Reimagination, and Redesign. There are some other factoids about our institute there. We do offer two master's degrees. One is residential. The other is an interdisciplinary master's in data science, policy, governance, and society. We have a Ph.D. certificate. We have an undergraduate minor. It's a concentration in data fluency for non-specialists, and a really unique intergenerational program called our Data Science Fellows. I've just put some QR codes on the next slide. If you are interested in learning more about these programs, because that's not the focus of what we're doing today, there's a QR code to some of our sample projects that our Data Science Fellows do. They are infusing data science content and curricula in faculty courses across the curriculum. And then on the next slide, I've got a link to both our center. So that's our Center for Responsibility, Reimagination, and Redesign, along with our online master's program in Governance, Policy, and Society. Thank you.
Great. Thank you so much, Linda. And Sarah, do you want to come on and tell us about Denison?
Sure. So I'm Sarah Supp. I'm located in the Data Analytics program here at Denison University. Denison is a 4-year residential liberal arts college in Central Ohio. So we're small. We only have undergraduate students, so we offer a Bachelor of Arts and a Bachelor of Science in data analytics. We have a total of 2,400 students here at Denison University. So a little bit different scale and level. We started our program in 2016, so we are about at 10 years with our first graduating class in 2019. So at our campus, the curriculum that we've designed is data analytics is what we've called it, rather than data science, because the focus is on broad applications across the liberal arts, so including those connections to many other disciplines and disciplinary areas. So our students do take some courses in math and computer science, but we have our own data analytics core courses, and then they all choose concentrations in other areas. So along the side of the slide, you can see the concentrations that we offer students so that they aren't just technical, but they can go out and actually apply their skills into specific areas where they've learned enough of that disciplinary content and terminology to be able to contribute. Currently, we offer biology, economics, earth and environmental science, sustainability, philosophy, physics, psychology, sports analytics is a new one that's very popular. And we also allow students to independently design their own, set of 3 or 4 courses that are this additional concentration area that they can bring to data analytics. We have a few others in the works, concentrations that hopefully we can start offering next year, as well as I've noted here a minor in data analytics, which we will vote on tomorrow. So that should be coming this fall. So in our nearly 10 years, we've graduated 228 data analytics majors. We currently have more than 200 majors, which given a student body of 2,400 is very large. So this has been a highly enrolled major. It appeals to a lot of students, both those that might be selecting between data science and computer science. They're already coming into college, technically minded, wanting to work in this field. But a large number of our majors, I think because we're interdisciplinary and sit outside of the STEM division, do come to us seeing data analytics as a means to an end to be able to achieve the goals they want, as the sort of students who probably would not otherwise choose to major in computer science or statistics. So I think that's a real strength, and also sometimes a challenge, but overall something that I'm really proud of with our program. This just goes over the way that our major is structured. So we do we're in our own interdivisional space here on campus. We are independent from the computer science or a math stats program. So we're our own thing, but the students will take the core courses in DA. They choose their specialization or their concentration. And then we have a really strong experiential component as well. So all undergraduate majors do a required internship or research experience between the junior and senior year. We have a practicum course where they work with external clients or partners on a semester-long project, and all students do a capstone research project where they put their data analytics skills to work. And then we can go over this if people have more specific questions about like building curriculum or scaffolding curriculum, but I just included this slide as a map of how our students move through our core courses and some of the cross-listed or elective courses to build up their data analytics skills to their bachelor's degrees.
All right. Thank you so much, Sarah. And for those of you who didn't get a chance to write everything down on that slide or want to see it again, we are going to circulate those slides with permission, of course.
Thank you for those introductions to your institutions and the stuff you have going on there. We're here for this kind of discussion, conversation part of this to talk about curriculum development, and both of you have a bit of experience in that space. So I think that the first thing that I'd like to do is just to ask each of you, you've done a little bit of this with your institution introduction, but maybe you could go over a little bit about your experience developing curriculum for data science and now potentially AI, if you've been doing any of that work. At what degree levels are you building these programs, and kind of what are your guiding principles? So maybe Linda, do you want to start, and then Sarah, you can follow on.
Sure, thank you. So full disclosure, I have an educational background, so the idea of curriculum development means maybe something a little different to me. But I, at Brown, developed our minor, the curriculum for our minor, but more recently, and a little bit bigger lift, was developing the interdisciplinary curriculum for our new online master's program, which again, I'm happy to talk more about that. But my guiding principles are really one of backward design, where we really start with the learning outcomes for our students. I also design programs from a learner-centered approach, which I think when you're teaching technical skills is really important. When you start to differentiate for different levels of student learners, your programs become more accessible for an array of learners. Because we do have a very interdisciplinary focus in DSI, we think that's really important, that it's not just the computer science and math students that are able to be successful in our programs. We really want to attract English majors and art majors. And I think about curriculum a lot. I think about disciplines a lot. And there's this idea that data science is something called transdisciplinary field, which means it goes beyond the boundaries of a discipline. And it's an interesting way to think about data science. So data science augments disciplines. It allows us to answer questions that aren't answerable. It allows us to look at data that we couldn't have done through our traditional disciplinary lens. And I think that is really embodied in a lot of what we do in DSI. We also have seed grants, the grad certificate, really training the future researchers in this idea of doing data science in their own disciplines. So yeah, happy to answer any questions about that.
Awesome. Yeah, we'll take some questions at the end in the last 10 or 15 minutes. But Sarah, do you want to go ahead?
Yeah, I feel like I should have been taking notes, Linda, because I agree with so much of what you said. So Denison's a baccalaureate institution, so we are focused explicitly on the undergraduate curriculum. When I came to Denison in fall of 2017, the program had just been approved by the faculty. So as myself and my colleague, Anthony Bonafanti, who's also still here at Denison, we're basically given the keys to the car and said, here's a list of courses, design them, make them happen, put them together. And so we went from a scaffold to being thrown into figure this out. And so, we use a lot of the same principles that Linda did. My prior experience before coming to Denison University, I'd spent many years working with the Carpentries organization. So folks are familiar with the Carpentries. That was pretty formative for my own thinking about educational design, lesson planning, modular thinking, et cetera. So I brought a lot of those to my own philosophy about what a data science major for undergraduates should look like, especially one that is meant to be interdisciplinary and to attract those, potentially those English majors or those history majors or biology majors or economists or whatever into this space and make it a welcoming, accessible environment for anyone who wants to use data, which I agree is transdisciplinary. Everyone benefits from knowing things about data. And so we did a lot of backwards design starting from, okay, we're hired to create this thing. What are the major level learning outcomes? From the major level learning outcomes, which of those are things that are exposure goals versus you need to build, which means you need multiple courses in which to go from foundations to intermediate to more advanced knowledge. Then within each of those courses, what are the learning outcomes that this course needs to be able to achieve by the end of the course? What are the prerequisites for that? That helped us set kind of where we needed to have strict prerequisites, so more of a hierarchical structure for parts of our curriculum, and where other courses in our curriculum could be positioned anywhere from maybe, let's say, sophomore to senior year, because that scaffolding aspect is really important. But we didn't want it to be so scaffolded and structured where if you don't start your first semester on campus, you can't be this major, because then you lose your accessibility, right? And your on-ramps into the field. So we didn't want to do that. So it's kind of this push and pull, but really starting from that backwards planning, and then figuring out how do you build up to that course to course to course. Starting with an introductory course that has no prerequisites, that does not assume any prior knowledge or exposure to coding, statistics, or data literacy, really. Do you even know how to make a folder on your computer? You don't have to get into the intro class. And that's been really important for us. And I think ultimately for why our major has grown to be so large, because we do have this nice on-ramp to get to the more advanced stuff. The other thing that is very central to our curricular design is that the experiential component is really, really strong. So our courses are all designed to be centered around project-based learning. And they also highly, highly emphasize what I've been told are now called durable skills, soft skills, human skills. Can you talk to other people? How do you emphasize the human value that you bring to a data analytics problem, whether that's through being an informed citizen, responsible or ethical use of your data analytics tools, being able to communicate in plain language to non-technical audiences, and making your work transparent and reproducible. And that's something we kind of use as a guiding thread through all of our curriculum.
Awesome. Thank you. So we touched on this a little bit, I think, in both of your responses, but I want to throw the wrench right into the works here and ask you, how has generative AI impacted your courses that you've designed, the programs that you're working on, and just sort of maybe generally your personal experience with teaching with this new technology in our labs?
Yeah, as with anything, it's something that faculty are talking about a lot. We're all adjusting to constantly. The way that I've been thinking about it with classes is, there's a spectrum, right? So you can have a class or a lesson or assessment that does not use AI at all, or that where you try to AI proof it. Like, is this something, that the student knows that they are not doing with the help of AI, that they don't need to rely on it? And then the other end of the spectrum being just full embrace of it. The students need to know this. What are they doing? How are they going to use it? How can they use it well? And so we're trying to come at it from both sides, I would say. And that's been both the opportunity and the challenge of this disruptive moment of generative AI is, I think, especially in the foundational courses, figuring out how do we design assessments or activities within our courses that are a little bit more AI proof, or where they're not using AI, so we can figure out how much of the core foundational knowledge of just the basics of problem solving structures or fundamentals of code or statistics are, here in the students' memories, is accessible to them, that they can recall, they can use it, they can do it responsibly, without having to rely on someone or something else. And so that has pushed us to where we had many courses that were fully project-based, so work could happen in and outside of class. We do now do more exams and quizzes that are on pen and paper than what we did before. And that's what I'm hearing is also commonly happening at lots of other data science or computer science majors as well. It's the opportunity has been, we've also started to add more things into our courses where we have some labs and some assignments that explicitly ask students to use generative AI and try to learn a little bit more about, pull back the curtain. How is it doing this? What is it doing? Where is it getting that information from? How do you vet the information you're getting out of it? How do you use it responsibly? How do you be transparent about where AI came into your workflow? And also from a professional preparation standpoint, what do you need to know to use effective prompting or AI assisted coding so you can be successful in an internship or a job? So we're trying to come from both ends of that spectrum and balance that. And where the balance falls out is a little different on foundational courses versus advanced courses. But it's tricky and it feels ever changing still.
Yeah. Thank you. Linda?
Yeah, no, Sarah, I think you hit on so many important points there. And I think it's something we're all struggling with. So if this is a big question for people, I think we just did a major task force at Brown and had a bunch of people looking and thinking at this. So there aren't any easy answers here. I like to just step back and think about this maybe from a little bit more of a meta level. But when I think about where I want to use Gen AI and how I want students to use it, I go back to my learning outcomes and what exactly are the skills that I want them to learn. And then where can we employ Gen AI where it does things really well? So, I like to think about this, and it also goes back to this idea of data science as this transdiscipline. If I'm a history concentrator, are there things that Gen AI can help me with so I can actually focus on the real meaty parts of the data science that I really want to focus on and have my students learn? And I think some of this is figuring out not just what the rules are, but tapping into student motivation as well. Are they intrinsically motivated to learn how to do these things? And again, we as faculty need to be making the case why they should be motivated to learn these. and so I think there are challenges about, really thinking thoughtfully about, well, why do you have this AI policy? Why are you not allowing them to use it? Why are you allowing them to use it? What do you want them to have? And also, I think conversations with industry are really helpful here, because how are they using it? And how are the folks in industry? Because if we're sitting here saying don't use it at all, and then they go to their first job and they're using it, we haven't taught them how to use it. And I can't reiterate enough what Sarah said about having students evaluate the output of these Gen AI, because as they're learning, I think we all put a lot of validity on Stack Overflow when we were doing that a few years ago, now that we don't do that anymore. And we know that there are problems with Gen AI and the output of Gen AI. And so how do we teach students to validate and think through those common sense tests of that? So, to me, it goes back. I raised 2 kids, and it's like that because I said so reason, I don't think is what we ought to be using with our students and Gen AI. And so maybe that's simplifying it, but, really thinking about what do we want them to learn, and why is Gen AI not appropriate or appropriate here? And what do you gain or lose if you use it or don't use it? So those are some of the questions I think about. And I do talk to students about those things. For our online program, we actually developed an AI philosophy. It's not the course policies, it's a philosophy on how we view using AI in our program, why it helps, why it may not help. And, we have professionals in our online program, but they were very receptive to reading about that and getting them to think about that. So again, a little different population than undergrad. Yeah.
That's very cool. If you have a chance later, maybe Linda, you could share that that sort of ethos with us. Go ahead, Sarah.
Yeah, no, if I can add one thing kind of to what Linda was saying, one thing that I found really helpful is, of course, as a faculty, you need to decide what those learning outcomes are and what's important for you to teach in your program or your major or your specific course. But one thing that I found to be really helpful at Denison too is just finding those partners across the institution to keep in the loop for that. So, I think there was some things you said, Linda, that reminded me of this, that, we have a really developed career center, for example, at Denison. And so working with those people as well directly to talk to them, or have them even come to a class where that's appropriate and say, what are they hearing from current employers right now about how they're using AI in their jobs, or what skills they expect students to be able to do. We also have an IT and also an ed tech centers on campus that have taken a real leading role for AI initiatives here at Denison. So not necessarily telling faculty what to do in courses, of course that's our job, but piloting a Denison AI program, pilot program that allows us to give students access to a closed generative AI system where they can experiment with Claude and ChatGPT and different things, and then compare the outputs. And that also really helps with some of these conversations. And they offer their own undergraduate training programs and certificates that I started having them come to the intro course and do at least the responsible AI introduction, just to kind of explain how it works, share some misconceptions, and some also just good rules of thumb and best practices for responsible and ethical use. And that's been really helpful, because then I'm not having to reinvent the wheel as a faculty member, and then I can build on those conversations as needed in my courses.
Yeah, that's great. I'm going to take this question that's just jumped into the chat because it's related to what we're talking about right now. So maybe both of you could share an example or a couple of examples of where you've actually had to redesign elements of your coursework to focus on the critical thinking in the face of the ability to use generative AI.
I'll throw one out there. I think in teaching maybe a more statistically focused class, one of the big hurdles for novice statistical students is which model do I use, right? And this idea of like just throwing something into ChatGPT GPT or generative AI and tell me what model I'm using. Yeah, okay, but again, is it right? Is it wrong? And so sort of circling back on that and saying, okay, connect that to, why, right? Why is that the right model? What out of the course materials is telling you whether this is the right or wrong material, so that they can start to connect, again, sort of triangulate what we're doing in class, what their problem is, and again, what was the output, and then sort of evaluating the validity of that. And again, automating some of the harder things. I attended a skill workshop for fun because the title was doing this with ChatGPT, and I thought the person designing the seminar did a really great job of saying, okay, you can actually input this data and it can help you decide, what the structure is and how these really weird nested things are happening in your data. And I was like, oh, that's a great way to sort of, again, take a look at it and then throw it into generative AI and am I on the same page with this? So, and I tell students on intro courses, like, yeah, you could do this course in a half an hour in generative AI. And like, what is that going to get you other than contributing a lot of tuition to our institution, which we love, but I'm not really sure you're getting your money out of that. So again, getting at that motivation of the students. So I don't know if those are helpful examples or not.
Yeah, totally. What about you, Sarah?
Yeah, I was trying to think about what I would want to share here, because I feel like this has been such an impact to a lot of my courses and how I'm thinking about assessment in particular. So, I mean, I mentioned one of the biggest things is that we had many courses that didn't have any exams in them at all prior to 2022, 2023. All of those courses have exams in them now because it just felt like it was becoming harder to know, especially in the first and second kind of levels of courses, that the studying was happening, and that there was a strong foundation of those basic concepts, because it's very tempting. It's very easy to use generative AI to get the answers, or to polish up a report or a data analysis project, or get the code to work. And that's great. But if you want really strong understanding, if you want explanatory power behind it, we just needed another way to do that. And so, so the way that grades are weighted across assessments that happen in class versus projects or assignments that happen out of class has definitely shifted to try to account for some of that. I think an interesting opportunity or change we've made is multiple of us have experimented over the last year with adding an explicit AI lab assignment into our Introduction to Data Analytics course. It's a 3-hour lab, so computational lab. They can come in and we've made it like a data visualization replication type of assignment. And the first time you do it, you tell students, I'm going to put this up on the wall. Here's something to replicate. You can use the entire internet, any Gen AI to do it. And I think they all think they're going to do it in 20 minutes. What it does is, in fact, by the end of 3 hours, we give them something hard. So the point is, try to use your tools and what you know to do something you don't know how to do. Learn how to do it and replicate it in a short amount of time. Most students aren't actually able to replicate it in 3 hours, even with the full capabilities of generative AI. But what it does do is it leads to a lot of these really interesting conversations then in breaking down the problem-solving process. And I think really reinforcing why it's the critical thinking component is essential to doing good data analysis with, well, before you started just dumping stuff into generative AI, like, what was your starting point? Or did you have a starting point? What were the variables and all the basic pieces? Because they often realize that they tried to bite off too much and then went off into all sorts of very confident but wrong answers that generative AI gave them. So that's been kind of interesting. I do a lot more oral assessment and discussion types of things in upper level courses as well, just to build those human skills. And we talk a lot more about, what your value is as a human and how you communicate that when you're getting ready to go off to internships and jobs as well.
Great, thank you. Um, so I want to zoom out a little bit. We're talking about AI right now, and everybody is talking about it all the time. We're kind of exhausted maybe by it. So let's zoom out and just sort of talk generally about the programs that you're developing. Um, Maybe you could share some specific pitfalls that you've seen that you'd like to make your colleagues aware of, to kind of say, "Hey, warning, don't make this mistake that we made," or something like that. So, any such examples you could share?
Yeah, I'll talk a little bit about our online development because Sarah, unlike you, I didn't even have the courses. We had an idea, and we decided to go in this direction of really this interdisciplinary space, which there were like two benchmarks for us to look at on similar things. So it was really unproven ground, and these courses didn't exist. And you know, I think in terms of, Sarah and I have both talked about some general principles of curriculum design, but I think some of the things that were really helpful for us that I've seen in other programs that we were able to avoid so far, is we did some serious curriculum mapping of our program learning outcomes against, what was in the courses. That served a couple of purposes. It helped us align the courses with the program, but it also allowed us to look at the degree of overlap among our courses. Some overlap is great, but too much is repetitive. And I think in these technical areas, we have a tendency to introduce hypothesis testing in every single technical course we teach, right? And so we worked really hard to avoid that. And if we were going to introduce something again, we said, well, you learned this in this class, but in this class, this is how we're going to use it. So students could understand the scaffolding of the content throughout these courses. And so I think that was really helpful. The other thing we really thought about were prerequisites for our program. I'm a data person, assessment person, so I want to know why are these prerequisites there? How are these contributing to student success? And I think too often we think about, oh, these are the prerequisites that are always on data science programs, so they have to be on ours. And I'm the person in the room who will say, well, why? What evidence do you have that has to be there? And I think, Sarah, you've got a very accessible program, so you've taken down some of those barriers. And I would encourage other people to really think about their prerequisites and why do they need them in that way. Are there other ways that you can get that information in? We've built a foundations course that allows us to get those in. And we actually do it in a really sneaky way, which is my other point is I'm not so sure. Again, I think about these things. We should just be teaching straight up technical courses. And I think Sarah spoke to this a lot. We're teaching technical at the same time that we're teaching fairness, bias, these policy implications, working with data quality. And this helps us get around the generative AI thing too, because it's like, yeah, run your data in generative AI, but you're going to have to write this white paper about what are all the problems with the data, what are limitations, and really get them to engage critically in the output of that. And that somebody had a question, like, how do we redesign? That's in large part how we've designed these online assessments, because the students do have to think about this work, and we have them not evaluating, but providing feedback on other people's technical work and critically thinking about other students' technical work. And it also helps differentiate instruction for students, because if you have students who are more technically advanced, they still have a lot to chew on, even though in the course I'm also introducing some basic things like using APIs and maybe some base skills, right? So if we weave these things together in our courses, then we've just sort of kind of taken, the rabbit out of the hat here and said, oh, well, wait, we can do all these different things in this course, because we're not just focused solely on this technical course, which again, I am increasingly thinking maybe that's not the right model we should be using anymore with our technical courses. So, I think we do a lot of collaboration with our courses in our course development. And again, we had a model that we were able to do that, but faculty tend to develop courses in their own little offices. And I think given the overlap, that faculty should have more conversations about what's in my course, what's in your course, how can we make these courses really work together. Yeah.
Yeah, again, I agree with so much of that. And I think we share a lot of those similar experiences here at Denison as well. Like, um, I think that that curricular map is so important for making sure the courses actually fit together and also revisiting it regularly as well. You know, I mentioned our program's been around about 10 years. Um, we've spent a lot of the last year basically redoing our curricular map and just checking, like, as the courses have evolved or new people are teaching them, does this still work for us? Do we need to revise it because we have generative AI now? Like, what does this map make sense, and is it still apply the way we think it does to our courses? And if it doesn't, then where can we fix that? Where can we make it better? And so I think that curricular mapping is, you know, I just reinforce, you know, it's something you don't want to get complacent about, keep doing it. I think part of where, for me, it helps as well as programs, data analytics, data science programs, I think there are many, many different models for how these work, how they get structured, where they're housed. Um, I do find a pitfall across many of these programs when I talk to colleagues at other institutions is stems often from the curriculum map, because if you're kind of cobbling together a program from, like, here's a technical course from this major and a technical course from this major, and then someone's going to teach this. As a faculty member with the big picture view, you might see how all those fit together, but are the students connecting the dots? Do they see why this class needed to come before this one? Are they using anything from this class in the next one if it's a prerequisite? And so I think that is really important for the success of our students as well, and the long-term collaboration of faculty. So we've also done a lot of collaborative course development, and we share what we're doing constantly with others who are teaching the class, so that while there's instructor freedom in how you teach a given course, they're not so wildly different that semester to semester, instructor to instructor, that we lose those common threads. When I speak with others at departments, I think just common pitfalls that are related to some of this is staffing, making sure that if you have, depending on how your staffing is structured, are you your own department or institute, or are you kind of borrowing people part-time from other departments? But then they have to get releases from their own department. Staffing can be a little bit of a constant treadmill if you don't have a really clear plan or percent of hours or courses that people owe to that data science program, and can lead to territorialism about who owns which class or which chunk of the major. So I think those are just pitfalls to be aware of, and to work really hard to build the community and the conversations you need around curriculum and scaffolding and staffing to try to avoid those festering into something that that causes a rupture in the program, or for it to not be very sustainable. The other pitfall I found is for projects that have a large experiential component or a project-based component, is if you're going to be working with external clients or partners, it's great. I think it's added a ton to our major. We were able to make an argument to our administration to hire a full-time administrative assistant, an associate director to our program, that really helps with a lot of maintaining internship pipelines and partners for our practicum and doing all that. It's a large amount of work for a single faculty member to do, and to do every semester over and over again. So for programs with experiential components, finding the staffing support for that can help it be more successful.
Great, thank you. So we've got some time left. I want to make sure we get to a couple of these questions I have on the page here before we close out. So the next one, so we've talked a lot, I think, about sort of what's happening at individual institutions and maybe some feedback that you might have for other folks trying to build programs and courses and such. To what extent do you think the community that we're in, the ADSA community, can create useful shared resources to facilitate curriculum development? And there's lots of things that could look like. And are there models in other fields for this kind of shared work that you would point to as a way forward for data science and AI?
Go ahead, Sarah.
It's a tricky one.
I'm thinking, I think some of the challenge in answering this question is that there are multiple curricular models and like program type models people use for data science or AI programs. And when I say that, I think that, I mean, there's of course, what level are you teaching at? Are you at a tier college, a four-year college, are you a master's or a PhD program or a certificate program? That's its own thing. But I think even regardless of that, that I think there's like three ways these programs can be designed that I see as pretty common. So one being there are a lot of data science or AI programs that are developed as a subset, essentially, or an offshoot of an existing computer science program, and they tend to be much more technically focused and much heavier the on like the computer science parts of, what I think of as the broader areas that data science relies on. There are data science and AI programs that are formed as a subset or an offshoot from an existing math stats department. And they tend to be much heavier on the mathematical and the statistical aspects of what it means to be doing data science. And then there are ones like the program that I'm in that are outside of either of those kinds of traditional homes, and they're their own unit and tend to be a broader interdisciplinary avenue into the field. And there's trade-offs with all of these, right? So, do you want to be a data science program that leans much more into the hardware, software programming issues? Do you want to be a data science program that leans much more into the mathematical underpinnings of what you're doing and the statistical or machine learning approaches? Or do you want to be something that's more interdisciplinary, but the trade-off might be broader courses, but maybe not quite as deep into some of the more traditional technical pieces, but broader exposure to applications. And so it makes it really hard to think about. I mean, there's not a one size fits all shared resource or scaffold or set of recommendations that I think works. I don't think, I think all of those are valid models, but I think in my experience, a lot of people are just hungry to have these conversations and maybe find other people that fit their program's identity group and then figure out what works or what are the pitfalls for this kind of program. And I don't know. I'm happy to brainstorm more about this though.
Perfect. Linda, any thoughts?
Yeah, I think, I mean, Sarah's points are all valid. And I also think there needs to be an alignment of like who your faculty are teaching these courses, because if you're doing a program like Sarah's and you've got some hardcore CS, and again, there's nothing wrong with that, but that may not be the best person to have in front of those students, right? And so again, I think it really goes back to, what do you want to do here? I think a very undervalued resource that a lot of us have on our campuses are our centers for teaching and learning. And I think ASDA could loop in some folks to really talk about curriculum design from that perspective, which is a little different than faculty who sort of jump on the curriculum planning bandwagon because we have to, and nobody trains us necessarily to do that. And so I think, those folks are great. They're great thought partners. They think about curriculum. Again, half my brain works on that level. So I'm going to maybe be biased in recommending those folks. But they also know your institution. And so I think they can be really great thought partners for you if you are thinking about these things, because they know the constraints, they know the politics of your institution. And those are really, really important to understand. I also think it's helpful to have touch points with external constituents. So if it's industry or the people who are hiring these students, what I don't think industry should drive our curriculum 100%, but I do think we should have an ear to the wall and be listening to them, because I think that is also going to help us understand where the field is going, because we do tend to be very slow to change in higher ed, and industry is maybe too fast, right? So where's that happy medium? So I think, those are, some of the things that, we can do. I think the other thing that we are seriously lacking in this field is empirical assessments of outcomes. We have tons of case studies on, I did this program, we did this course. Okay, yeah, but what's the so what here? Like, where, show me, right? Show me the data. We're data scientists. We should be collecting data and understanding student outcomes. And that is not grades, by the way. I'm not, it really is about, can the students do these outcomes? Like the AACU has like a gen ed process for evaluating student learning. Maybe modeling something like that for data science, where we collect artifacts from all these programs, and are our data science majors really learning what we want them to learn? And so there hasn't been that sort of broad scale research, I think, in the data science education field. And I do think we have plenty of case studies now. Our field should be stepping up. And again, I would turn to the folks in your education departments for help with those, because they're really good at measuring student learning. So some collaboration there could go a long way.
Great, thank you. Last question for me, and then we can take some questions from the audience if we have time. Let's talk a little bit about the accreditation machine. So that's up and running for data science and undergraduate. And I wonder maybe if you could talk about sort of where that fits into the picture for your institutions and how you're thinking about accreditation in this space.
Yeah, so I do come out of an education background, so assessment and accreditation is part of what I was sort of brought into the academic world on. And I think it's really, really important, again, that we are assessing what we're doing, not just for accreditation, but for our own, formative feedback. This might be controversial, but I think it gets to Sarah's point. There's no one size fits all. When I think about data science as this transdiscipline, it gets really hard for me to really figure out what exactly we should be assessing in data science, right? Is it all of these technical skills, or is it the ability to use these technical skills in these other disciplines? And I'm not saying one is right or wrong. I'm just saying I have questions about exactly what that is, because I still have trouble some days thinking about, well, what exactly is data science? If you don't have a discipline attached to it, what are you doing? And again, I know my brain probably works, and everybody on this panel is like looking at me going, what is she saying? But it's an interesting thought question. What is data science if you don't have anything to do it on? So again, I'm not anti-accreditation at all. I'm a big assessment proponent, but I do think, we kind of have to sort of figure out, to Sarah's point, there's so much variety across the ways we can deliver this education and what those student outcomes are. Accreditation is measuring student outcomes. So, to have standards across all programs could be missing some of the richness that is going on in some of these innovative programs. So again, I'm not saying no, I'm just saying to me, it's hard to really think about at this point. Sorry.
Yeah, again, I feel pretty similarly. I think data science is still really hard to categorize as a field. And I worry some about, in our effort, I want to know more about what other people are doing. I want to know more about the different ways we might classify ourselves as data scientists or data science programs, and how that might help us learn from each other, think about what we're doing and why we're doing it. But I worry that if we try to standardize it too much, we might really constrain what we're teaching, what our students are able to do in the field, interdisciplinarity and creative applications and growth and innovation. So yeah, and I've seen a few efforts that have come from other disciplinary homes, again, to try to classify things that data scientists do or things data scientists should be teaching and at what levels. And they look really different if they're coming from a group of statisticians, or if they're coming from a group of computer scientists, or if they're coming from a group of biologists. And I think that's okay. So I actually think that's part of what we can benefit and figure out what fits the flavor of a particular data science program or institute or student body. But so yeah, I don't know. I'm kind of interested to see where this conversation goes, but I think it would be unfortunate if the end result ended up unnecessarily constraining the field.
Great. We have a question in the chat that I'll try to convey. So this is from MC Ramos. So going off the idea of thinking about assessment, would you be willing to share some of your thoughts on rethinking assessment for online? And you talked a little bit about this, but MC is kind of concerned about over-reliance on AI for doing assignments. Pen and pencil solutions can answer that, but maybe you could talk about the online space.
Yeah, I mean, it's online education. I've been engaged with it for a long time. Assessment is always challenging in the online space. And again, we it gets, and again, I'm dealing with older students, professional. They have to have been out working in the world. So these are not, fresh out of undergrad programs, but do you want to use generative AI to do your coding? Is that what you want to get out of this program, is to learn how to use generative AI to code? And again, I think these are choices that we need to present for students. And if we want them to be able to code and to be able to demonstrate, then, we maybe use a proctoring service where they're doing live coding and you have the browsers clamped down so that they can't be using generative AI to do that. There is technology there. It's expensive, but it does work. These professional proctoring programs are amazing, right? So you can lock down the browser. All they have is their coding environment. That's the only thing that they can work in. And so you can clamp down anything else going on. I've had experience with them. They work really, really well. We've taken this other approach where it's, hey, let's, encourage you not to not learn how to code, because that's why you're paying the money in the program to learn this stuff. But really thinking critically about what is the output. And again, my thinking is that, well, if they get out into industry, they're probably going to use generative AI to run these very simple descriptive statistics that we're teaching in this class. Okay, again, if you don't want to know how to do that, that's your motivation. But, again, in our program, we also want them to really engage with the data. And I think that ups their motivation to produce the data. It's not just produce the data and turn in the assignment, it's produce the data. Now I have to get in there, I have to think about this, I have to write this response where I'm really interrogating this. So I don't, the proctoring service, if you just want to go at the technical, we're going out something a little different. I don't know if that's helpful or not, but that's where our thinking is.
Yeah, thank you. Looks like we have a recommendation for a book, Online Learning Analytics, from Taylor and Francis, as an option from Jay Leibowitz put that out here for us, and a link. So you can find a link there in the chat. Do we have any other questions from the audience or from chat that folks, I think we have time for maybe one more. Then I will ask the final question. So, of course, the AI and of course and data also, these issues and topics are not exclusive to our departments and our programs. And so, how have you been pulled in or volunteered yourself for conversations more broadly on campus about integration of generative AI into the classroom, or have you really just sort of been sequestered into your department and that conversation is happening elsewhere? And we've just got a couple of minutes, so we'll be quick.
I'll just say, if you go to my slides, our data science fellows program is literally helping. I have junior and seniors technical students helping faculty to develop the content for these courses. And you can go into our website and you can see the array of projects that we have. It's not just AI, though. It is broader than that. So they look a lot differently. And one of the things when I came to Brown and started the program was the faculty were like, no, it's not the student stuff. It's the faculty need help doing this, and the faculty need to be supported. And so anyway, it's a win-win, because our students are, to Sarah's point, developing the soft skills, this experiential component. These are open-ended problems. They don't have a right answer. They're just great for students to have to chew on for a semester. So I would encourage, thinking about, well, what experiences would our students benefit from, and how can that then benefit these other faculty on our campus? Because we do have students who can do this kind of work, who can think like this, and who need these hands-on experiences and managing their own project. Now let's put these two together. So that's our Data Science Fellows program if people are interested.
Awesome. Sarah, any closing thoughts on that topic?
Yeah, I mean, I'd say the conversations happen both within our department. So we have 7 core faculty. We meet regularly and we talk about, like, what are you experimenting with in AI? How are you changing assessments to avoid AI? How are you changing them to include AI? So, I mean, there's a lot that's happening within our department. But I think across campus as well. I mean, we are on a small campus, so there's maybe stronger community connections and integration that we're able to have with other departments than maybe are typical at a really large university, just as things scale up. I have a colleague in my department that here in data analytics that has presented with our faculty symposium back in August, was centered around AI, generative AI in classes, and attended by faculty from all different disciplines, including the arts and humanities, and presented examples about what she's doing in courses. I have another colleague that worked together with a group of folks from math and CS to propose, and it will be offered starting in the fall, a machine learning and AI minor. And so that's something that will be available for students who want to learn about those things as an add-on to their regular major starting next year. I'm co-leading with faculty from several other data liberal arts colleges, a data analysis and AI workshop that's going to happen in July, where we're going to work to figure out kind of the landscape of what are students thinking, how are they using it, what are faculty thinking, and develop some conversations or maybe a project or a set of recommendations that come from that. So yeah, just
awesome.
Keep thinking about it.
Yeah, well, thank you both for speaking to us today. It's been great to hear about curriculum development and your experiences, and maybe you'll get some questions from attendees coming straight to you later on. I just want to note that our next Builders series will be on April 16th, and we'll have Rachel Saidi from Montgomery College and Helen Byrne from Highline College talking to us about data science and AI education at two-year colleges. There's a link on the chat there, and you can also find a link at the ETSA website, and you'll probably see an email from us soon. But thank you all for attending. This has been great to have you here, and we'll look forward to seeing you at the next Builder series.
Thank you.
All right, thank you.